Hi everyone, I'm Nimakin. I'm a Year 4 BA student from University Technical Malaysia Malacca. I would like to introduce my bachelor degree project, which is development of pick and place robotic arm using Arduino, the poster video and also the demo video. So before I start presenting my both video, I would like to thanks to my supervisor, Vanero Kausa, who's giving me a lot of guidance and support in my bachelor degree project. And also thanks to Encik Sulaiman and Encik Maslan for spending time to watch my video. Now, let's move on to the presentation. Hi everyone, I'm Lim Wai Kit. Now, I want to present the poster of my project. My project is given title The Development of Pick and Place Robotic Arm Using Arduino. From this poster, we can go through the introduction, problem statement, objective, scope of project, the research methodology, result and discussion, conclusion, and also the reference of my project. So first, what is the pick and place robotic arm? Pick and place robotic arm speeds up the process of picking up and placing components or objects in other areas. Automating this approach helps to improve the output rates. This project is to design a smartphone-controlled robotic arm by using Arduino. MIT app inventor is used to develop a mobile app to control the movement of robotic arm by connecting to the Bluetooth module. For the problem statement, currently most systems are using control panel to control the movement of robotic arm. It will require the manpower to be at the place to control. If the process is repeated for a period, the risks of injuries increase. If the robotic arm is used in a dangerous environment, for example, when the robotic arm swings substantially, the robotic arm will wear and tear. When the robotic arm is operated under such conditions, it will increase the possibility of injury to the operator, which may cause serious physical injury. The objective of this project is to design and develop a pick and place robotic arm. Second, to develop an application to be integrated with Arduino microcontroller as a system. Third, to analyze the performance of the developed robotic arm. This project focuses on the design and development of the pick and place robotic arm to perform a repetitive task of pick and place. The robotic arm developed is a 4 degree of freedom robotic arm. Arduino Uno is used as the brain of the system, and servo motors act as the joints of robotic arm. The results of my projects is divided into two parts. First part, manually controlled by potentiometer. Second, smartphone controlled by Bluetooth module and also the mobile app developed. By moving the servo motors, the Arduino robotic arm can rotate 180 degrees to pick and place some objects from one place to another. In the research methodology part, the flowchart of the system developed is shown. First, the Android apps developed will send the data packets, which means from the Android apps developed, the user moves the slider to give the value of degree for the servo motor to move. Next, the Bluetooth module will receive the data packets from the Android apps. The Arduino will send signals to servo motor as per the value of the data packets. Then, the servo motor will be able to move according to the value of degree given by the user. Therefore, the robotic arm able to do the pick and place action. In the results part, there are two figures shown in the result. The first figure is the Android apps developed by using MIT App Inventor. The app is simple. There are connect and disconnect buttons displayed on the screen, and 4 sliders used to control 4 servo motors. Next, the second figure is the prototype of the system. The construction of the DIY robotic arm and the whole system will be explained in the demo video later. For the analysis result part, first I do the time response analysis as the distance go farther. However, I figure out that The time response is almost the same whether the distance is nearer or farther. Then, I do the analysis of the performance of the developed robotic arm. There are three parts that I do analysis, which is button vs slider, Bluetooth vs Wi-Fi, and servo motor vs stepper motor in motion control. First, the slider control can change to varying degrees, whereas the button control can only shift to values that's set by the user only. Therefore, the slider control is more flexible compared to the button control. The servo motor can be shifted forward and backward by a slider, which is more appropriate for robotic arm movement. The button is not acceptable because it just goes forward and does not go backward. This is not appropriate for robotic arm movement. Bluetooth module and Wi-Fi module have their own benefits and drawbacks. Bluetooth module is regarded as wireless short-distance communication, while the Wi-Fi module offers more permissions and long range. In addition, the other two important factors are speed and power consumption. The Wi-Fi module is better in these two factors compared to the Bluetooth module. And last, because of the quick reactions to disturbance, the servo motors are best suited for the synchronized motion, while the stepper motors may start or be slower to respond to the disturbance. Besides, servo motors have high torque levels at high speeds, something that stepper motors do not do. In AC or DC drives, servo motors can operate and do not suffer from vibration or resonance problems. There are some weaknesses in this project. First, the DIY robotic arm cannot withstand heavy mass objects. Second, the servo motor cannot shift too fast to avoid the joints falling off from the robotic arm. The third weakness is sometimes the connection between Bluetooth module and the developed Android apps will be lost. As a conclusion, the proposed concept of back-and-place robotic arm using Arduino is implemented via Bluetooth module and the mobile app developed. The developed system able to do back-and-place action. So that's all for my poster presentation. Thank you. So hi everyone, I'm Mikey. Now I will start the demo of my project. Before I start the demo, I will introduce the construction of my DIY robotic arm and also the whole system. So first, I use the body board print corrugate sheet to do the body part of the robotic arm. Then I use 4 servo motor to act as the joints of the robotic arm. The first servo motor acts as the base, second servo motor acts as the shoulder, the third servo motor acts as the elbow, and the fourth servo motor acts as the gripper. This is the Arduino Uno board. It will act as the brain of the whole system. And this is the Bluetooth module. The Bluetooth module is blinking means that it is not connected to any device. But when it stops blinking, it means that it already connected to the device. So for the Bluetooth module part here, I do the voltage divider circuit. This is because the voltage supply from the Arduino Uno board is 5 volt. But the optimal voltage for the Bluetooth module is 3.3 volt. Therefore, I do the voltage divider circuit here to reduce the 5 volt into 3.3 volt. Another benefit is that the voltage divider circuit also make the components to not malfunction. And here is the 4 resistor and also 4 potentiometer. And this one is the capacitor. The use of the capacitor is to filter the noise. This is because the voltage across the resistor is not completely linear. So the result of my project can be divided into 2 parts. First part, the manual control by potentiometer. Second part is the smartphone control by using Bluetooth module and the Android app developed. So now I will start to demo the first result, the manual control by potentiometer. And this is the object that I use to do the pick and paste action. So you can see that the first demo, the manual control is successful. It able to do the pick and paste action. So now I will start the second demo, the smartphone control by using the Bluetooth module and also the Android app developer. So this is the Android app developed using the MIT App Inventor. So now I'll start the second demo by smartphone control. So first I need to connect to the Bluetooth module. And you can see that the Bluetooth module stopped blinking and connected is displayed on the screen. So it means that it's already connected. So now can do the pick and paste action. Oh, sorry, I mistake. I do the so disconnect and reconnect again. So this is another one of the weakness. This is because that there's still many space in the gripper, so it means that it cannot hold the object tightly. So now I will try again. So you can see that the second demo is also successful. The smartphone control can control the movement of the robotic arm. So that's all for my demo. Thank you. So that's all for my poster video and also the demo video. So thanks for all for spending time to watch my video. Thank you.